Recently, I've been thinking that I should stop using RX and actually really learn coroutines and flow and stuff like this. And I didn't make the switch yet. And today I'm going to talk about RX. And I think what I'm going to talk about is more principles you can apply to any, like it doesn't really matter if it's coroutines, RX, or whatever. Just the way you organize your data can make a big difference on the simplicity of your code. And so just keep that in mind, even though I'm going to be RX oriented. So let's talk about effective reactive architecture. One of the main principles that I like is the side effect isolation. And to do that, I'm going to show first some real code that we had in our app that I stumbled upon and decided to refactor. But then Keynote just wanted to fuck me up, so I had to use a PDF. So we don't have animation, sorry about that. So we have a profile view, which is basically an avatar name normal thing. The view has a navigator to switch views. We have the name view. An app service will be the proxy, either calling the network on your database, it doesn't matter, and a name subject that will use to kick stuff. So first on the onStart, there was a name subject. So every time a new event is emitted, we switch map, call the profile. From the profile, extract the prefix, and then mix them both. If the name is empty, we don't do anything. Otherwise, we put the prefix before it. And we subscribe, so it updates the text view we have. Same, I don't know if it's still a thing, but there was a bug that if the hint was set and the hint would be longer than the actual value of the text, the width of the text would be longer than required. So we had to, if there is a name, set a hint, otherwise send it to blank. And again, we subscribe to the subject. When a string is emitted, we subscribe and update the hint. Lastly, we get the profile and subscribe to it by just populating the profile. The populate profile is just, as you'll see, it's gonna be tricky. Now we kick the name subject saying, oh, we have a name for you. And then we'll be rendering the other things, which isn't important. And so let's say the user on the dialog change their name, and now the onset name dialog result is getting called. So we call the set name, which surprise called the name subject. And then we actually call the service saying, OK, now I want you to update the name. And depending on the response, we either kick again a string into the subject, or if there is an error, let's say we just move away. So let's imagine data is coming and just let's see what's happening. So the first two name subjects are just listening to value to come, so nothing's happening. Now we get a profile, which populate profile. It kicks name subject, so it goes up top. We call the profile again, use the prefix, do things, and update the text view. Then the other subject is kicked as well. We get the name. I don't know if it's empty or not, doesn't matter. We update the hint. We populated the profile. OK. Now let's say the user updated their name. We go into set name. We kick into the subject, which should have been basically what we've done at the top again and again. Then when we call the service to update the name, same. So if it's an error, we don't really mind. We go away. Otherwise, we kick again to the subject, and the whole process happens again. So I think this is madness. When I saw that, I wasn't happy, and I thought there was better ways to organize the data. And I think a way to detect that it's really messy is to just highlight the side effects. And there was an extra surprise. Let's say you depend on the database for the profile, and some other service or something updated your profile. Everything just starts again. The subject is kicked and everything. But so when you isolate side effects, or when you highlight them, you can see how things are really tangled. So the name subject, we'll call it a reading, which is basically just we are listening for stuff from the user to happen. The blue would be business logic, so every time you want to call something out of the view, could be the database or the network. Then the red would be the writing when we want to update the view for the user to see. So here we just update the text. We do another read for another write. Getting the profile would be a side effect, business side effect. Populate the profile would be a writing. And within the writing, we do a reading again. And even in set name, we do some reading, some business logic side effect, and we kick a reading again. And this doesn't look really good. And so I decided to refactor it. And this is how I did it. So first, I created a class for the events just to list what the user can do. At the moment, there is only the edit name event. We take the new name that the user wants to give us. Then I have a result class, which could be considered a business logic result. So every time you update the name, every time you get a profile, these get wrapped into a result, so it would be easier to model into the stream. So we have the profile result, and then name valid or invalid when you update it. And just the view model that the view would just use to print to the screen. And so it's not the view model of the Jetpack thing, it's just the state of the view as a class. So we have stuff we don't really care about for now, and so I have a prefix name that I just set into a class which embeds the logic of the naming, the prefix and the name. So now, the tricky thing was to think what was the code actually achieving. And so to me, we just start with the reading. Give me all the events that the user can execute, and then we'll react on them. The publish method is just basically having one stream, splitting it into substreams to, at the end, merge them back. Right now, we only have the edit name, so it's not really relevant. And at the end, only, now we have view models. I want the view to update it, to use it to update itself. And that's the only place when we would write anything on the view. So if we have we set the hint, the text, and the rest. And now within the publish, every time we get, so we filter the instance of edit name, then we kick some logic, which was the same as before. We set the name, and depending on if it's valid or invalid, we either emit a valid result or invalid result. And if you remember at the first implementation, we would kick the subject, so basically updating the view, then calling the API to update the view again. And it was just an optimistic way of changing the view. Basically, we would say to the customer, you updated your name, but actually in the background, we would actually update it. And unless there is an error happening, the user would not realize it. To do that on streams, you just add a start with, saying, even before calling the network, saying, we have a name valid to update the view at the end. Now, because we also wanted to react on profile changes, we just merge all the events logic to the profile and wrap it into a profile result. Now, we use the scan operator to just take all those business logic results and create a view model from those. The scan, you pass it a default view, a default value, which in our case is an empty view model. And then you have a buy function, which is basically, as you can see for the parameters, you have your view model, which at the start is the default one. And just every time you get a new business logic result, OK, what do I need to update into my view model? And you just do that in the buy function. And so about scan, even within my own team, we have a lot of talk saying it's kind of can be overkill, can be complicated. and we tend to rely a lot on combine latest, which instead of having multiple streams that you merge back into one within the scan, you just combine latest all the streams and then build a view model every time from scratch with it. It might look easier, but I think it is really tricky because combine latest would expect all streams to emit at least one element, otherwise nothing gets kicked. It's really easy to forget the default view model, and it's been, I don't know, we had a lot of problems with the combine latest approach, so I think scan is the right move. So every time we get a result, we have name valid and invalid. When the name is valid, we just take our view model, update what needs to be updated, which is the name. If it's invalid, we don't do anything because we were actually navigating away. The profile, when we get a profile, we just update the rest, and because there is a name within the profile, we update the name as well. And so when the user updates the name via some dialog, we just emit the event, and that's it. So let's see how the data flows in this case. So the events at the top, unless they get they accept an event, nothing's happening. So the first thing happening is we receive a profile, which emits a result. So it updates the default DMT view model to taking the profile and the name. And then when subscribing, we just render the view. Now when the user updates their name, the event logic kicks in. We filter it, call the set name, and then start with kicks right array. So we update optimistically the screen for the user. It goes into the scan, update the view model with the valid result. Then the API actually gives us a response. If it's invalid, we go away. If it's valid, it's the same. We go again into the scan, update the view model. We could add some distinct until change somewhere if that makes any difference. But anyway, and so side effect-wise, if we start highlighting those, we have one reading at the top. We set name, so business logic. We get a profile, business logic side effect again. And then in the subscribe, we just write to the view. And when the user wants to update the name, we do a reading as well. And that's all we have. And compared to before, where there was reading, business logic, writing, reading, some reading into the writing, these kind of things, now everything is just splitted out. And when we checked how the data flows, there was never the data going back up. Like when you would kick a string into the first name subject, you would have data going down, then kicking something up, and it's really, to me anyway, it's really hard to reason about. And now everything is just going from top to bottom, and that's it. And so we have one stream. Let's say we want to test stuff or create a presenter or whatever. After the refactoring, everything within this pink area has nothing to do with the view. The view only listens for the user's events and then writes something back. And because we were able to isolate those, now everything in the middle can go away from the point of the view, and which is what we'll want to put into our presenter. And so we could just put it into a method, but presenter has states. So we're going to make it a class. And it's not really easy to just take this part of a stream and put it into a class. But so that's why we'll see the options we get for that. So first, we want to take the events and passing those to the printer. There are a few ways to do this. I don't think it's exhaustive, but that's what I've seen so far in our code base. Now would be to think the presenter is a consumer of events, so we just define it as is. And what really sucks about this is that the consumer APIs has an accept of an event. And even though we had an observable of events, now we are back to a non-reactive world with just one event. So you cannot do, you cannot react on it, do a flat map, or whatever, everything that RX provided us. You need to subscribe it into the view because the presenter, as a consumer, is now subscribing to the events. Then you need another subscribe on the presenter to get the view models back. This is horrible, and I don't recommend. Another option would be to pass the events, let's say, into the constructor. And within the constructor, you start putting your old business logic again, publish, and emitting the view model somehow back to the view. I think it's fine. Nothing fancy about this. The third option would be, instead of passing it to the constructor, you pass it in a method. I think it's fine again. And so now, from the presenter passing back view models to the view, again, few options. You just get a method, maybe view models. The view could subscribe to it. All is fine. Another option would be now to think that the presenter is a source of view models. So you just define it as an observable for now. It would work, I guess, but so the observable is a class, quite heavy. If you want to be, I don't know, efficient, maybe you don't want to take all that, which would mean now you could only do the observable source, which is an interface with only one method, which is the subscribe. The inconvenience would be that so you only have one subscribe method, which includes the observer, so you'll have to override all methods every time, which isn't really handy. There is a wrap method for the presenter, which turns an observable source into an observable. It's fine again. We actually use that a lot, even though we've been fighting over this a bit. And so I want to go back to how the streams was defined. So if the presenter would not be a class but a method, the signature would be, we put events, stream of events, we want a stream of view models back. That would be a signature really simple, and that it could be one method of your presenter, but it's actually something that the RxJava provides as an observable transformer, which is the same signature for the apply. If we take the upstream, rename it to events, and downstream to, so upstream event, downstream to view models, that's the exact same signature we had. And you just implement the interface, and bang, you have it. And you just need to implement the apply method. What I like about this is now when you actually, from the call site, you don't pass the events to the presenter or to the presenter method. It's events, presenter, view model, so it keeps the same ordering of the way the data flows. Super easy to test. Instead of subscribing, you test it, and then pass an event. You assert that you have a view model. It's basically input, output. There is no magic at all. It's really easy to test, and anyway, really easy. So I have a few opinions about presenters, and this is my, not a go-to list, but whatever. The presenter, to me, should not break the stream. What I mean by that is, if we have a stream, we should not go back to a non-stream and then back to some stream. So the same with what we saw with the consumer. If we have a stream of events, we should not break it and then have one event that we need to wrap again into an observable to do some things. The presenter should not start anything until the view is actually subscribing to it. And this is something I actually saw in our database as well. When into the constructor, we would subscribe to the, the database, bound it to some view model relays, and then the view, when subscribing, would get the latest value of the relay. Rx should be lazy until really required, and until the view subscribes to the presenter should not do anything. Like, nobody would be benefiting from this. The presenter should not handle disposables. So basically, the presenter would be just one pipe of the stream instead of having its own lifecycle management. I put a star on it because it can be tricky if the presenter has to live longer than the view, and we'll talk about this later. And then for simplicity, I think the presenter should have only one entry point and one exit point. So instead of having the presenter exposing set name, set picture, whatever, you only take events, and then the event class would embed everything and return one view model, and not returning new name, new image, anything. So thinking is good, but config changes are a thing. And so let's say the presenter needs to live longer than the actual view. And so we could use the Android view model APIs or anything else. But so there was a few tricks with this. Right now, the stream starts from the view. And so when you, let's say, rotate the view that gets destroyed, the stream source actually gets destroyed as well. So the whole stream just dies. So all the logic, all the cache, or whatever you had into your presenter just goes away, even if the presenter instance stays on, because the source of the stream died, nothing is kept. So the presenter would have to have a subject or relay to hold, like, it will be the actual source of the stream, and then the view would just be, by the way, take my events and put them into your events. And so this would be a pass event method. And so let's talk about subject quickly. I think subjects are good in two cases. One, when the lifecycle differs. So in our case, when the presenter lives longer than the view, subject is nice. And actually, I don't think there is much other ways to do this. And the other time is just when you have not a stream that you want to stream. If you have a stream, and at the end you have a stream, in the middle if you have subject, I think that's a sign that there might be improvement, room for improvement to do. But so anyway, so we have our events, and then let's say we just get a method for the view to subscribe to, returning the business logic, namely the view models. This is tricky as well because the view is the subscriber, so when the view dies, the whole stream gets disposed as well. So it goes now back up to the presenter's event, and everything in the middle is gone. So if you have a state, you rotate and want the same state to be emitted to the newly created view, you need a cache for that, and now your stream just went away again. So that means that the presenter needs to wait for the first view to subscribe and then keep a reference to the stream. So even though a view just would be destroyed, the stream would lives on. The way I do this in this case would be, so I have an observable of my view models within the presenter that are waiting to be called by the lazy, what is it? The lazy keyword, whatever. So the first time it's called, we actually kick the business logic, which subscribes to everything upstreams, and it's fine. And then we keep a reference. So every time a new view would act for the view models, we would just have the stream ready. And we need to fulfill two things. When a new view comes to the presenter to subscribe, we need to send back the latest state that we had. This is the replay. So replay is just on new subscribers, this, give the last state that we have. And auto-connect is to make it so that we have a first view subscribing, it dies, that means there is no subscriber left. In this case, even if we have a replay, the whole thing dies. Auto-connect 0 means that, so it basically subscribes automatically, even if there is no subscribers, and it stays subscribed to, even if the other subscribers just dispose themselves. So that's what happens when we have the presenter, the first view is here, subscribe, dies. The auto-connect 0 would say, I have 0 observer, I'm still okay, so the stream still lives on, and a new view comes, and so we get the replay 1 and the latest state. So that's how I would manage config changes in our app. At work, we don't really care about config changes, so we don't do this anyway. And so on the call side, in this case, you'd have first to listen to the view models, and then pass the event. So the ordering is important because otherwise you might pass an event without, and a view model will be emitted even yourself before, even that anyone is actually listening to it, so that the view model could be emitted into void. And so this is something we actually saw, and I just want to be explicit about this, which what we call the unidirectional data flow. So we have the view and the presenter. The presenter is just the business logic. And the view, which I think is really tricky, is on one class, on one hardware, whatever. We have both, as we talked about, the writing and the reading. And I think it's much better to just split those and see them as different. And after the refactoring, what we had was the reading at the top, business logic, and then just at the bottom, the writing. And so this is the principle I have. When we read, we should embed all the data required for the business logic to do its stuff. So the reading goes to the business logic. Then the business logic just emits a view model, which then gets written to the view. The business logic should never call the view and say, by the way, what's the value for this field? No, this should be embedded into all events. Any payload you need should be, the view should give it to the presenter and not be pulled by the presenter. Same when we write, we should not be like we did, we update the name. Can you call the server now to update the name again? This is a no-no. Again, when we write, we should not be, by the way, now that I wrote a new text, maybe you can read this field and do some logic. This is madness. If there is no logic, maybe some reading could kick some writing, why not? And as I said, the other way around is a no-no. So that's what we have. That's what I try to respect every time, and it's usually a good rule of thumb. So what if we want to add some new feature? Let's say, so that's what we have right now. And so let's say now the user can change their avatar. So we had the event, the view model. We need a new event, which would be the change avatar, and maybe the user just selected a file from their file system. The view model would just have a UI for us to show or whatever. And within the subscribe at the bottom, now from the view model, we take the UI and just use Picasso to load it into our view. This is the presenter we had so far. The whole edit name logic is now into some logic method. So we need to add a new logic for the change avatar event. So we filter the event, then call the server, change avatar. When it's successful, we wrap it into an avatar valid result. If this is an error, we do the same. It doesn't really matter what we do. In the scan in the by function, because it's one statement and result was a sealed class, it would fail anyway and would tell us that we need to take care of the avatar valid and invalid. When the avatar is valid, we just take the latest state that we have, update the UI. When it's invalid, you can do anything. And basically, that was it. We just defined a new event. We have two new results, one new field in the view model, and you just update the different parts of the reading, business logic, and then the writing. And so what I think is really nice about this is that the way we organize our data just forced us to separate things. It would have been really difficult for me to use a writing, update, like basically mix writing, business logic, and everything. Everything was just in its spot, reading, business logic, writing. There was no need to modify actual code, so it might depend on the way you do tests as well, but I would expect the test to just pass without getting updated for the whole test anyway. It's easy to test as well because it's an input-output stream. We give a change avatar event. We just assert that at the end we get a new UI for this. That's all we have to test. And same for when you review, you don't have to, to follow the data going back up or down into subject. And oh, by the way, when this subject, subscribe on, whatever. This is just step by step. And so there is a nice trick you can do with the Kotlin extension function to organize your data, because if you have many events, you have events publish, so we split the streams into for each event, then at the end merge them back. This can get really long, and so what you can use extension function to just wrap the logic into some method, which here would be at the bottom change avatar. So it becomes a one-liner, and then the logic itself lives in some method somewhere in the presenter, which is just an extension function of on the typed observable, and you emit something. So we use it a lot, and it makes the code easy to read. And so navigation, it's something, especially in the MVI architecture, which is talked a lot about, and I don't think it's assigned a lot. We found a sweet spot for this, and so I wanted to share it anyway. So we have a navigator interface. We just pass it a screen. In our case, it's passable, but it doesn't matter. We use the same design for launchers if you want to actually launch intent to URL or share or whatever. But so let's focus on navigator. This gets injected into a presenter, and so it can be either the view saying the navigation is me, but it's just a lambda, or can be upstairs from above. And so let's say we have a new event, go-to event, and we have the go-to logic. In our case, the only thing we have to do is do on next, because do on next is for side effect. Now we have a navigation side effect. We just go to somewhere. The navigator might just take the view, tears it down, put a new view instead. The presenter should not care about, should not know about this. Now that we consume the event, we should just ignore elements, which means that the emitted event doesn't go downstream. So now it becomes a completable. And just to make the type system happy, we just cast it back to an observable. And so we use this pattern a lot, and we also have a small helper method that just, instead of doing do on next, ignore elements to observable every time, we just consume on next and speak for itself. And so for the test as well, we have a fake navigator. We just emit an event and assert that the navigator properly navigated to some screen. And yeah, we've been pretty happy about this. And so what we saw, so as a summary, we had side effect isolation. You don't mix reading, writing, and business logic. Everything is just isolated. The data doesn't go sideways, doesn't go spaghetti style. It does only from top to bottom to reading, business logic, writing. And even though we didn't talk about this, everything was immutable. We never changed anything within a view model. It was always a new view model created from the previous one. And this makes things much simpler. And that's all I have for you today. Thank you very much. Yep, I don't want to take question on the mic, so if you want to talk, please come forward. Thank you.